Hello,
Sure.
motion viewers. Welcome back. If you watched our previous episodes, you may be very familiar with Mr. Tom Hafer. Mr. Hafer develops systems for neutralizing rockets and drones. He currently coaches teenager robotic teams. They met in the MIT Free Speech Alliance. Today, Mr. Hafer is going to present Starship. Good afternoon, Mr. Hafer.
Afternoon, Dr. Liu. Good to see you again. And yes, Starship is a very interesting subject about which I knew very little. So it took a lot of research to find out what's going on. And I still don't know, but I'll tell you what I have found out. The Starship test. What happened and what does it mean? So first of all, what is the Starship? So Starship is the biggest rocket that has ever been built. It's about 400 feet tall. And this compares it with some of the other space launch systems, some of the biggest ones. And Starship is really two different rockets. This part down here, up to the actual Starship, is called the heavy lift booster. And then on top of that, the second stage, which separates and is its own rocket here, is the actual Starship. And so that is shown over here. And the Starship itself consists of a large tank and motor section, which has liquid oxygen and liquid methane and 6 rocket motors down here. And then the cargo space up here, which can hold crew or cargo or whatever you want. And then it has a header tank up here, which can provide fine control of pitch and yaw of the rocket. So it has about the first stage, the heavy launch stage, has about 17 million pounds of thrust, much more than any of these other rockets. And then the upper stage Starship, once it separates, has about 3 million pounds of thrust. So what was it supposed to do? I apologize, this diagram's kind of hard to see, but I'll walk you through it. So there were 3 separate stages of this. First, down here is the actual launch stage, which it did. And then it is supposed to fly out and go up to a distance of 100 miles or so. And then it executes a peculiar maneuver where it actually flips, and in the process of flipping, separates the Starship from the heavy launch booster. And then the heavy launch booster continues the flip and then turns itself around and is supposed to come back and land normally back at the same place where it launched from. But in this case, it was going to ditch in the ocean. It wasn't going to be recoverable. And then the Starship was supposed on this flight to fly out for another several thousand miles. And then it would also do a turn maneuver. And then it was also going to ditch in the ocean. That's what was supposed to happen. Let's see what actually happened. So here's a very sped up clip of the actual flight itself. So you'll notice from the movie that there were supposed to be 3 things that happened. The first one, which was the launch from the pad here, was successful, but the launch pad was all torn up and big chunks of concrete flew all over the place. And it's not inconceivable that some of those concrete chunks actually went back up into the motor section and damaged some of the motors on the heavy launch booster. And part of that is because not all of the motors in the heavy launch booster, we'll show those in a minute, actually worked successfully. And so when this, in the process of launch, it actually slid sideways a bit, and it may have gotten into part of the launch pad that wasn't intended to absorb the thrust, and that may be why there was so much concrete thrown around. So then it did fly out, and then you'll see when it gets near the end of the film that it is actually spinning. It's flipping. And here it is, and there's the heavy launch section, and then you'll see here the Starship section is at an angle, and so it appears that they did not attempt to separate the 2 sections, but it appears that something broke right here. And so it was obvious that the flight was not going to be successful from there on out. And so then they issued, the system didn't blow up. It was blown up by range safety. It's what's called a flight termination system. And that's included in every rocket of this type, every unmanned system. In fact, drones have them. The only thing I would note is that if this had been a manned flight, the people probably would have been able to get out safely because there would have been some type of an escape pod up here in the Starship itself. And so they would no doubt have ejected that. So the problems that cropped up were several. One, there was the question of why didn't all the launch motors ignite? And then later on in flight, you'll see some of them actually failed subsequently in flight. And in fact, what happened was that when it got up here near the place where the flip maneuver was scheduled, the central section of the flight motors have thrust vectoring. They're gimbaled. And so they can actually control the attitude, that is to say, the direction of the missile, whether it goes like this or this or this. And the gimbals failed. And so then the asymmetries in the thrust of the motors that were still functioning caused this to flip. So even though it looked like it was doing what it was supposed to, it actually wasn't. So that was another problem. And then the other problem is that while the flight termination system did work, it took about 40 seconds, and that's unacceptable. It's got to work right away when you want to terminate the flight. So they've got some problems that they've got to solve. So let's look at these motors. So here's a bottom view of the heavy lift booster, and you can see there's this whole array of motors in here. And these ones in the center are the ones that are supposed to be gimbaled and provide attitude control. And you can see that partway through the flight, 3 of them did not ignite on the pad, on liftoff. So that caused some asymmetries in the thrust. And then later on in the flight here, you can see that 1, 2, 3, 4, 5, at least 5 of the motors have failed. So they've got to find out what the heck is going on. Now, NASA, and probably many in the public, think that this was a big failure, and it certainly wasn't a huge success. But Elon has a different attitude. He says success is far from certain, but excitement is guaranteed. And his view is that this is an experiment, that he learned a lot from it, and next time he'll do better. So what's the overall Artemis program? Well, this was just the first section of Artemis 1, which is just to prove that the heavy launch system and the Starship work, and they were going to do a suborbital flight. In Artemis 2, they'll actually circle the moon with the Starship, and then in Artemis 3 is where things kind of get fun. Here, they're going to circle the moon, but then land at the South Pole. Because there's water that's been found in a crater, Clavius, I believe it's called, at the South Pole. And they'll bring a dune buggy that looks kind of like this. There'll actually be 3 people on the mission, but one will stay in the Starship, and then 2 of them will drive this buggy around the moon. And then things get more fun because there's a whole series of Artemis missions that, if they're all executed, would eventually result in a moon base. So this just shows an early stage moon base that might be in Artemis 4 or 5, and then as things progress, they would have a real moon base with permanent structures and solar panels and vehicles and a number of people staying there. Because with ice on the moon, you have most of the ingredients for what you need for sustained life, because you can use the ice to make water, of course, which humans need, and which is one of the heaviest things that has to be supplied. But you can also use these solar panels to electrolyze the water and make hydrogen and oxygen. So the oxygen is used for breathing, and the hydrogen can be used as fuel for things that aren't compatible or aren't efficient with solar panels. So that's the idea behind the Artemis series.
That'll be our first time to build a base in the moon, and for permanent time, right?
Yes. Yeah, we had no intentions of establishing a base when we went there 50 years ago. But now, at least the plan is that we do. So that's a good introduction to this slide. So what good is a moon base? Why do we want to go back? We went there 50 years ago. What's the point? Well, a bunch of things have changed. So first of all, we did not know at the time that there was water on the moon, but that's since been discovered in the Clavius crater at the South Pole. So that provides the means to sustain a lunar base. Second, the economics have changed. If Starship is successful, it will cut the cost of delivering material to and from the moon by a factor of between 10 and 100. Third, some types of manufacturing that require low gravity or vacuum could be more economical. For example, the production of very large crystals, nanoparticles, and also products for local use, such as solar panels. Also useful for low gravity scientific experiments, terrific for astronomy. They've got unlimited real estate and no atmosphere. Military applications. So you can turn those same telescopes around and look at the Earth and use a very large array and get very high resolution images. Also for rapid access to space. The moon's gravity is much less than Earth, so it takes much less energy to get up into space and into orbit around the moon. And lastly, my own invention, but gigajoule lasers. Again, no atmosphere. The lasers could shine wherever they wanted without interference from atmosphere or clouds. And so in sum, the moon might become the world's biggest spy balloon. A base station for to Mars. You can have some of the materials transported to the moon or manufactured on the moon, and then get them up into space and have them join with other rockets from the Earth for refueling or whatever to make it easier to get a rocket up to Mars. There's tourism.
Fly me to the moon.
So, how many billionaires might like to take their girlfriend to the moon for a weekend? Wouldn't that be exciting? And then last but not least, the mining of high value minerals, especially Changesite Y. Now you're probably going, Changesite Y? Of course. Why didn't I think of that? That's so obvious. And so we'll get to that. So basically, this creates a new space race because of all of these reasons above. And so nobody wants to lose the space race. So that's why we're doing this now. So what the heck is Changesite Y? Well, Changesite Y is an ore that was brought back by a Chinese lunar mission that contains significant amounts of helium-3. Now, what the heck is helium-3? Well, helium-3 is an isotope of helium. That means it's the same element as helium, but instead of having two neutrons, like sort of normal helium over here, it only has one. So this gives it some interesting properties. Mostly, helium-3 can power a fusion reactor that is highly effective and has very little radiation hazard because no neutrons are generated and no spent fuel is generated. Now, why are neutrons bad? Well, neutrons are like little bullets that come out of a nuclear reaction, and they go through practically anything, and then they can damage the cells in human beings, and they can cause materials to become radioactive, and they're very difficult to stop. It takes a heck of a lot of shielding. But protons are different. They're different because they have charge, and so the charge makes them effectively a lot bigger. So neutrons are like shooting a bullet into the woods. It can go a long, long way before it finally comes to rest somewhere. Whereas protons are like shooting a basketball into the woods. It's going to hit something pretty quickly and stop. So that's the difference. And so down here, we show some of the nuclear fusion fuel cycles. So right now on Earth, we've got these two isotopes of hydrogen, deuterium and tritium, and they can be fused together in a reaction that produces a neutron and helium-4, regular old helium. But there's this messy old neutron. So yeah, we can do it, but it's dangerous. We can use a deuterium-deuterium reaction, which has two has, one of which produces a neutron and helium-3. So again, that messy old neutron. But down here, when we use helium-3, either together with deuterium, we get a hydrogen nucleus and helium-4, and it produces a large amount of energy. Or we can use helium-3 plus helium-3, and that produces 2 hydrogen ions and a helium-4, and also a large amount of energy. So these reactions are potentially world-changing because 200 tons, which is the weight of 3 M1 tanks of helium-3, could potentially be used to power the entire Earth for a year.
Incredible. So, how much Changesite Y in the moon compared to the Earth? We don't have any in the Earth.
Oh, as far as I know, there is none on Earth. There is some helium-3, but it's much, much, much less frequent than helium-4. There's not that much helium-4, but there's almost no helium-3. So the Changesite Y is probably about the only effective thing that we could get helium-3 from, and that would pretty much have to be mined on the moon. But I want to point out that just because we get the helium-3 back here to Earth, there's still a lot of technology to be developed. This is, among other things, an extremely high temperature reaction, hotter than the surface of the sun. So containment of that reaction, along with some of the other problems, is going to be a big problem. But before I finish up, I want to mention that presentation is being brought to you from the rocket room. And why is it the rocket room? Well, I'll show you why. There is a model of the Atlas missile, which was our first intercontinental ballistic missile, in which I saw lots of them take off and blow up, and some of them even flew when I was down at Cape Canaveral. And then alongside of it is a profile model of an RPG, which is a rocket that we do our anti-tank rocket defense systems against. And then down here, a drawing, a painting by my grandmother of that same Atlas missile taking off from Cape Canaveral. And over here, a photograph of one of the successful flights of our rocket in a box system, which if the Army had adopted would be really useful in Ukraine right now. Finally, over here, we have a picture also by my grandmother of that Atlas missile flying successfully through the air. So that's all from my days at Cape Canaveral when I was a boy.
I think we want to send people to the moon or send the rocket to the moon next year, right? Do you think that it's failure? No.
It's not going to happen next year. I mean, you're correct. It says that we're going to go there in 2024, but that just isn't going to happen that soon. It's going to be at least 2025. I mean, first of all, they do have some serious problems that were illuminated by this flight that they need to solve. But also, you know, you've got to be very careful when you send people to the moon, and they're not going to take chances with that.
Yeah, that's right. Okay, great. Thank you very much for the presentation, and I look forward to talk to you next time. Bye-bye.